second experiment which the students will be doing here is the heat balance test. And so the heat balance test, so what is the basic purpose of this experiment? Here for the operation of the engine we need to give the energy input. So that is, the energy input is by supplying fuel, and the fuel undergoes combustion, and so that is the energy released inside. So that is the input to the engine. So that is the heat input corresponds to the fuel consumed, right? And we know, according to the thermodynamic principle, only part of this energy is converted into work. So that is here brake torque. So we need to measure, we need to understand what happens to the remaining energy, right? And any good engine will give me around the 30%, 35% only maximum efficiency. So that means majority of the heat input is lost. So I need to find out what ways these energy is lost, so that I can devise some mechanisms, devise some energy recovery systems, and so that I can improve the overall performance of the engine. So that is the purpose of the heat balance test. Here also you will be asked to do the experiment at different load levels. So that is for this engine 0, 6, 12 and 18, 24. So like that you will be asked to do the experimentation at different loading arrangements. So you know from the performance test how to load the engine, how to measure the fuel consumption. So that has been already explained to you. So now here for measuring the various losses, here the various losses I am measuring is for the cooling the engine. We need to circulate cooling water, right? So otherwise the engine becomes so hot and it would stop actually. So there is a separate cooling water circuit is there, and through that the water is circulated. And so just generally, so there is a rotometer here, and this rotometer is normally you will be instructed to set at 200 liters per hour, 250 liters per hour, or so the instructor would already been set this, right? So there is 2 rotometers, so one for the engine and one for the calorimeter. So calorimeter I will explain later. So through the cooling water circuit, the cooling water is circulated around the engine jackets, which picks up the heat, and we need to find out what is the amount of heat carried away by the cooling water. So the amount of heat carried away by the cooling water is calculated using this relation: mass flow rate of the cooling water into specific heat into temperature difference. Specific heat of water, approximately we know it is around 4.18 or 4.2 kilojoules per kilogram degree centigrade, and the mass flow rate of the water is actually, this gives you my liters per hour. From that I can find out what is the kilogram per hour. So mass flow rate of water is also can be known. Only thing is I need to know the inlet and outlet temperature of the cooling water. So there are measuring jackets, I mean the temperature sensors are available, which actually measures the inlet temperature and the outlet temperature of the water, which is directly, so this is I think the inlet temperature, and this one is the outlet temperature of the water. So automatically with the temperature sensors, right, and with the arrangement which is available over here, so these values will be automatically recorded inside. Okay. So basically you need to set the load on the engine, and for finding out how much heat you are supplying to the engine, I need to measure the fuel consumption. So anyway, as explained earlier, you need to load and you need to measure the time for fuel consumption, and you need to measure what is the inlet temperature of the cooling water and outlet temperature of the cooling water. So this is mentioned as T3 and T4. T3 and T4. So then this is done. So next I also want to know how much heat is there in the exhaust gases, right? So the exhaust gases carry lot of amount of heat with them. For that I need to calculate. So this is again calculated from the relation mass flow rate of the exhaust gases into specific heat into temperature difference. So for calculating the mass flow rate of the exhaust gases, I have what is known as an exhaust gas calorimeter. So the exhaust gas calorimeter is nothing but a heat exchanger where it transfers the heat from the exhaust into a water which is circulated around this heat exchanger. Basically it's a shell and tube heat exchanger where you have a gases and also water is circulated. So the heat from the gases goes to the water. So I am just making an energy balance where the heat lost by the exhaust gases is equal to the heat gained by the cooling water. So that is mass into specific heat into delta T of the water is equal to mass into specific heat into delta T of the gases. So the gas inlet temperature to the cooling water, gas outlet temperature to the cooling water, right? So this is the inlet temperature to the cooling water and this is the exhaust gas temperature from the cooling water. So all these is recorded here, and the cooling water inlet and the cooling water outlet temperature to the exhaust gas calorimeter, that is also is measured. So automatically at that particular flow, then making the energy balance, we are finding what is the mass flow rate into specific heat of the gases, and then multiplied by the exhaust gas temperature minus the ambient temperature will give me what is the amount of heat carried away by the exhaust gases. So I am just finding how much heat supplied to the engine, and by measuring the fuel consumption and by measuring the load on the engine, I can calculate what is the brake power of the engine. So that is the useful power I am getting from the engine. So what is the energy that is being converted into brake power, that I am calculating, and then some amount of heat is carried by the cooling water, that also I am calculating, and some amount of heat is carried away by the exhaust gases, that also I am calculating, and the remaining heat actually what happens to it is lost by radiation, convection, friction and all other means which we are not calculating here. That all the other heat I am just grouping them into what is known as an unaccounted losses. So finally you have to draw the heat balance chart, right, which is nothing but taking the load of the brake power in the x-axis and the cumulative percentage on the y-axis. So then that experiment is done. So this you need to take readings at 6 kg, 12 kg, 18 kg and no load. Maybe 4 readings will be asked to take, and with the help of the readings you need to construct the heat balance sheet. So that completes my heat balance sheet example.